Hi, welcome back. This is Professor Rage in today's lesson on section 5.4, Properties of Logarithmic Functions. And so let's start with the product rule. If we have the log base A of m times n, we get log base A of m plus log base A of n. What helps me remember these rules is if I remember that a logarithm is an exponent and we have the corresponding exponent rules. If you have a to the x times a to the y, remember you're going to add the exponents, x plus y. And you can actually prove this logarithm product rule using the exponent rules. Because again, logarithms are exponents. A logarithm equals an exponent. Okay, so if I had log base, say, we'll just say base A of 5x, there may be instances that I want to split this up, so I get log base A of 5 plus log base A of x. And then I create two smaller logarithms. Okay, so that's the first rule. The next rule is the power rule. Okay, so log base A of m to some power, we're going to bring that power out in front and multiply it with the log base A of m. Okay, so you can bring the power in front. And again, the corresponding exponent rule would be if you take a power to a power, you're going to multiply the powers. So that's the same idea. Okay, so the way you could use this, again, is you can bring that power out in front and multiply it with the log base 2 of 8. So 8/5 is a pretty big number, and then 2 to the what power is 8/5. You may not know that without a calculator, but using this property here, you could see that log base 2 of 8, well, 2 to the 3rd power is 8, and see, this will get you 15. And I could do that without a calculator. So it's a nice little property. We're going to use it a lot when we're solving equations. Okay, and then the quotient rule, if you take log base A of a quotient, m divided by n, you could split that up into the log of A, log base A of n, minus log base A of n. And I won't show you an example of that one. Alright. And then a couple properties about inverse rules. We know that log base A of A to the n, well, those basically are just canceling each other out, and we just get n. Okay, so we're saying A to the, if we got log base A of A to the n, we're saying what power of A is A to the n? Well, it's obviously n. Okay, so that's an inverse rule. And also, if you take A and raise it to the log base A of x, you get x. And so I think of those, basically they're canceling each other out. If you take log base A and you write the number a to some power, well, the log base A and the a to the power, those cancel each other out, and you just get what the power is, n. And then a to the power log base A, again, those are canceling each other out, and you just get the x. So let's look at an example. If I had log base 2 of 2 to the 3rd, see, we're saying 2 to what power is 2 to the 3rd? 2 to what power is 2 to the 3rd? Well, right, that's a no-brainer. It's already written as a power of 2. So the answer is 30. If I had a to the, not a, let's do 7 to the log base 7 of 49, and again, what we're saying, for the log base 7 of 49, we're saying 7 what power is 49? Well, that's 2. And then 7 squared is 49. So we can just basically cut to the chase and skip that middle and say, by this inverse rule, 7 to the log base 7, well, those cancel each other, and our answer is just the 49. Okay, so if I had 5 log base 5 of 37, 5 to what power is 37? And now do 5 to that power, so you're obviously going to get 37. Okay, may have forgot to talk about this one. Log base A of A, well, that's just basically using the inverse rule. That's 1. And log base A of 1, so it doesn't matter what the base is. That's going to be 0. So those are two important ones too. Okay, a to any power, a to the 0 power is 1. Any number to the 0 power is 1. So log base anything of 1 is going to be 0. Okay, express as a sum of logarithms. So basically we're going to use the product rule. So log base 2 of 8 times 64 is log base 2 of 8 plus log base 2 of 64. And then we can work both of those out pretty easily. We're just practicing splitting this up right now, so we don't have to simplify further. Log of 0.2 x, so that's log 0.2, and remember, if there's no base written, it's the common logs, base 10, so it's log base 10 is just log. So log of 0.2 plus log of x. Okay, so you can take products and split them up. If you had log of 3xy, well, that would be log of 3 plus log of x plus log of y. Okay, now let's practice the power rule. Express as a product. Log base a of x to the 4th. So remember, you're going to take the power and bring it out in front. So it'll be 4 log base a of x. So it's 4 times. You don't have to write the dot, but just want to accentuate that or emphasize it. Now this one usually gives people trouble. Log of square root of a. And you got to remember that square root is 1/2 power. So now I can bring that power out in front and have it 1/2 natural log of a. And again, I don't need to put the dot there. It's there. Okay, now let's try expressing as a difference. So subtracting, we use the quotient rule. Log base a of 76/13 be log of a. So the top one's first, minus the bottom one. Log base a of 13. Okay? Alright, let's try, we don't need to do another one. Let's try doing a combination of these all together. Okay, so I'm going to split this up. I got x cubed times y squared times z, so I'm going to split it up into 3. So log base a of x cubed plus log base a of y squared plus log base a of z. And then I'm going to use the product rule, or power rule, and bring them all out in front. 3. I'll bring all the exponents out in front. So we're going to get log base a of x, 3 log base a of x, 2 log base a of y, and then log of a, log base a of z. Alright, so we can split it up that way. Let's try another one. Log of 5a over 5b, or 4b squared. So log, we're going to split the division part first, so log of 5a minus log of 4b squared. Now, remember, there's parentheses there, you got to think of it that way. So when I split it up, it's log of 4 plus log of b squared, and bring the 2 out in front, and then you got to distribute that minus sign. So we're going to get log of 5 plus log of a minus log of 4 minus 2 log of b. And usually what I tell my students is, you know, with a tiny bit of practice, it doesn't take a lot of practice, but with a little practice, you can jump to this bottom line and just kind of keep in mind anything on top will be positive. So look at the 5 and the a were on top, they're positive. The 4 and the b squared were on bottom, those are negative. So anything on top will be positive, anything on bottom will be negative. Okay, so let's try just to jump to that last line there. So anything on top, log of 3, plus, and then powers you just bring out in front of each individual one, plus 2 log of x. And again, anything on top will be positive, log of y. Anything on bottom will be minus, so minus 3 log of w minus 2 log of z. Alright, so it doesn't take a whole lot of practice, and you can kind of do the whole thing at once if you want. Okay, so one way we can use those properties is, you might know, be given log base b of 2 is about 0.693, log base b of 3 is about 1.099, and log base b of 5 is about 1.609. Find each of the following round nearest thousand. So I might give you something like, what's log of 5/3? Now since we don't know what b is, we wouldn't be able to, we'd be stuck, right? But since we have these properties, you know the log base b of 5/3 is log base b of 5 minus log base b of 3. And now, since we're given those approximations, log of 5 is 1.609, and log of 3 base b is 1.099. And then you can punch that in your calculator or do it by hand, however, and you get 1.609 minus 099.51. Okay. If I want to do log base b of 30, here you got to realize, oh, that's 2 times 5 times 2 times 3 times 5. So that's going to be log base b of 2, log base b of 3, plus log base b of 5. And we're going to put in, we're doing approximates, so now this is approximately. 2 is 0.693, 3 is 1.099, and 5 is 1.609, which is going to be 3.401. Alright, let's do one more. So if I have log base b of 15b, well, that's log of 3 times 5 times b I'm not going to write that down. So that's log of 3 plus log of 5 plus log base b of b. That's going to be 1.099, 1.609, and log base b of b is 1. And that's going to get me 123.708. Alright. So sometimes you got to get a little creative with those problems, and then you can use properties. And based on just those few given logarithms, you can figure out a whole bunch of other ones. Okay, so that concludes the lesson for 5.4. Go to my math lab and complete your exercise there. See you next time.